Hello everyone, welcome to our channel. I am Paige Wise, and today we are going to dive into a fascinating and somewhat disturbing topic. Is our life a simulation? Do you believe this statement is unrealistic? Hold your horses, because it may look like there is a really high chances that yes. To understand this idea, everything starts with Ludwig Boltzmann and his contributions to physics, and it ends with a brain floating in space. Ready? Let's go. Ludwig Boltzmann was an Austrian physicist from the 19th century, born in 1844. He's best known for his work in statistical mechanics and thermodynamics. These disciplines focus on understanding how physical systems behave at a microscopic level and how these behaviors determine the macroscopic properties of matter. Boltzmann introduced the idea that the macroscopic properties of systems, such as pressure and temperature, can be explained in terms of the statistics and dynamics of individual particles. In particular, his famous Boltzmann equation describes the distribution of particle velocities in a gas in thermal equilibrium. But the most interesting thing for us is his statistical interpretation of the second law of thermodynamics. Boltzmann proposed that order and disorder in a system can be understood in terms of probability. In other words, the universe we observe might, and it probably is, result of one of many possible random configurations of particles. To put it in simpler terms, the universe as we know it is a product of chance, particles moving randomly and, by pure luck, creating the foundations of everything we have today. It's like rolling the dice and bam, the result is the universe as we know it. Despite the brilliance of his ideas, Boltzmann faced a lot of resistance during his life. His contemporaries did not easily accept his theories. Many scientists of the time firmly believed in a deterministic universe and found it difficult to accept the probabilistic and statistical implications of his work. Boltzmann suffered severe criticism from prominent scientific figures of his time. Boltzmann, however, remained convinced of his theories, despite the opposition and isolation he faced. Tragically, in 1906 died, deeply affected by the lack of recognition and constant pressure. It was only after his death that his ideas began to be accepted and appreciated. Boltzmann's statistical physics became a cornerstone of modern physics. A significant shift occurred when Max Planck, initially a critic, adopted and promoted Boltzmann's concepts. Planck, while developing his theory of blackbody radiation, realized the usefulness and accuracy of Boltzmann's statistical mechanics, leading to a broader acceptance of these ideas in the scientific community. During the time when Boltzmann's ideas were highly criticized and mocked, some of his detractors posed a question. If by chance the foundations of our actual universe were created, wouldn't it make more sense to believe that, instead of an entire universe, what was created was just a brain hallucinating the universe? This would be more probable since the complexity of a single brain is lower than that of the entire universe. These critics didn't realize that they were formulating one of the most interesting and profound theories related to the reality simulation theory. Imagine that, instead of a whole universe filled with galaxies, stars, and planets, what randomly formed was just a brain floating in space. This brain, known as a Boltzmann brain, would have a series of perceptions and memories that make it believe it is living in a coherent universe. Everything this brain experiences would be an illusion or a simulation, a series of hallucinations generated spontaneously by itself. The idea is disturbing and radical. If we are indeed Boltzmann brains, then our entire reality, including this video, our memories, and our experiences, could be just an illusion, having possibly formed just a few seconds ago as particles randomly aligned to create not only our reality, but also our memories. Everything we know and believe could be a mere illusion. It's not that every person you know is a Boltzmann brain. It would be just you. Everyone you know would be part of your own simulation. Even your own body will be part of the simulation. This sounds kind of weird, but think about it. What is more probable, the development of several brains as it's supposed to be, or just one? You don't even need to think of something as improbable as the existence of a single Boltzmann brain out of nothing. Perhaps what was created randomly is the foundation of the Boltzmann brain you are, and you have evolved to experience the simulation in which you, as a Boltzmann brain, exist. This possibility leads us to question the very nature of our existence and our perception of reality. If Boltzmann was right about his math, and remember it looks like he was, it is more likely that we are a Boltzmann brain than part of a more complex system. Even if we are not Boltzmann brains, given the vastness and age of space, we can assume that the existence of Boltzmann brains is a mathematical certainty. There are some questions that arise from the Boltzmann brain theory. If we are a brain floating in space, why is the simulation we are in so complex? Shouldn't it try to optimize itself to consume fewer resources? The answer is yes, but hey, maybe it already does. Let me explain. Video game developers usually use what is called a game engine. These engines try to make developers' lives easier by helping them develop games faster. Additionally, the best game engines are optimized to the max to increase compatibility with older devices. In video games, what costs more processing power is rendering images. During the execution of a game, only the things inside the player's view are rendered. This is similar to how our reality works. Our universe is vast, but our range of vision covers only a very small portion of it. We can take this even further with the double-slit experiment. This experiment shows that when particles are observed, they behave differently than when they are not observed. This is similar to a video game where the system collapses and renders scenes logically but not visually until they are observed. Another technique that developers use to optimize systems is LOD, level of detail. LOD changes the shape of objects to reduce their complexity the farther away they are. Our perception appears to have a similar system. Objects seem to lose detail the farther away they are. In video games, developers usually tries to set limits to the world in which the game is happening. Looks like this is different from our reality, right? Wrong. Our reality also have observational limits. The speed of light sets a limit on the speed we can move, but if you also combine it with the expansion of the universe, it also sets a barrier that we can explore. Just as there are limits to what we can observe in the vastness of the universe, there are also limits at the microscopic level. These limits are governed by the principles of quantum mechanics. For example, Heisenberg's uncertainty principle states that we cannot simultaneously know both the position and momentum of a particle with perfect accuracy. This introduces a fundamental limit to our ability to observe and measure the microscopic world. The Boltzmann brain paradox makes us question the very nature of our reality. Do we live in a simulation? Are we just floating brains in space? The answer remains a mystery, but these ideas invite us to reflect on the depth and complexity of the universe we inhabit. If you enjoyed the video, don't forget to subscribe, and hit the bell icon so you don't miss our upcoming videos. Let me know in the comments what you think about these theories. Do you believe we live in a simulation? Thanks for watching and see you next time. This was Paige Wise, expanding horizons together.